This is the first of two videos that are going to attempt to explain the really important concept that's known as shrinkage. And I'm going to use the process of simulating data to try to explain this concept. So I'm going to assume that we're going to go out into the forest and we're going to randomly select 5 large parent trees. We're going to get cones from those parent trees, and from each parent tree we'll get 5 seedlings. We'll measure the height of those 5 seedlings and we'll construct the following statistical model. See that y ji is equal to mu plus ti plus sj nested within I. So this is going to be seedling height. And we'll have 25 of these values because we've got 25 seedlings, 5 seedlings per parent tree, 5 parent trees. And this is the intercept that will set to be equal to 0. And this is the effect of the ith parent tree. So this is the parent tree effect. And it's going to be derived from a normal distribution with mean 10 and standard deviation equal to 2. And this is going to be the seedling effect. And it's going to be drawn randomly from a normal distribution with mean 0 and standard deviation 7. So with the 25 seedling heights in hand, we can make a plot. Before doing that, I just want to emphasize what we're interested in this particular case is going to be the parent tree effect. Now that's a little bit counterintuitive in the sense that what we've got here is a random tree effect and a random seedling effect. And normally in a model that's just got random effects, what typically we would be expected to be interested in would be the variance of the parent tree effect and the variance of the seedling effect. However, what I'm going to assume here is that we got our money to do this research from some sort of a company. And we're interested in publishing a paper based on these parameters. But to satisfy the needs of the research grant, the company would like to know, it's got these trees growing out in the forest, which one of these parent trees in the forest ought they select to put in their seed garden so they can make new seedlings. So, although it's not always the case, in fact it's fairly rare when you're really focused on these components to also be interested in individual tree effects, we are in fact going to be interested in these parent tree effects. And the whole idea is we could obtain a naive estimate of those parent trees effects, and we'll see that, or we could obtain a shrunken estimate, and what we're going to see is the shrunken estimate is superior. So we've got these 25 seedling heights, and here we see a plot. So what are some of the important features of this plot? Well, this horizontal line right here is the average seedling height. And it's about 10, which is not terribly surprising because the intercept was equal to 0. The random parent tree effect had a mean of 10, and the random seedling effect had a mean of 0. So when you average over the 25 observed seedling heights, it's not surprising that they would be close to 10. These stars of David, these are the tree effects. So you've got 5 values that were obtained at random from a normal distribution with mean 10 and standard deviation 2. These little black dots, each one of these little black dots, there's 5 of them per parent tree, these are the measured values of the seedling heights, so the observed values of the seedling heights. They were obtained by adding the intercept of 0 to the parent tree effect plus the seedling effect. And these diamonds, what are these diamonds? These diamonds are arrived at by adding together and obtaining the sum of those 5 individual seedling heights. So for any given parent tree, this is the true value of Ti. Well, we wouldn't observe that directly. What we would observe is this value here, the average of its 5 seedlings. So now what I want to do is focus in on this thing here. And we're going to see that we've got a bit of a problem. So this value here is the true parent tree effect. And it obtained from a normal distribution right there. But the observed values, represented by these black dots, you can see there's a fair amount of scatter because those seedling effects were driven from a population that had a very high standard deviation of 7. So there's our 1, 2, there's a third one here slightly hidden, 4, 5 seedling effects. And what happens when we average them all up? When we average them all up, what we get, this is the observed average of the 5 seedlings, and you can immediately see the problem. The true value of the parent tree effect is a Star of David, but if we just looked at our 5 seedling heights, we would conclude that it was equal to this observed value here. So there is a discrepancy that we need to take care of. So how are we going to do that? Well, what I'm going to do is clean this up a bit, getting rid of this. And now what I want to do is think about what's happening in this case, where the seedling effects were drawn from a population normally distributed with mean 0 and standard deviation 7. We repeated the process, whereas in this panel, the seedlings were drawn from a normal distribution with mean 0 and standard deviation much smaller, a value only of 1. So as a consequence of these values of the seedling effect, now drawn from a population with a much smaller standard deviation, you can see that the scatter around the Stars of David is much smaller, and the observed average of those 5 values is very close to the true tree effect. So in this case, we've got no problem. The naive estimate obtained by simply by averaging the 5 observed heights is pretty close to the true value. But if we compare these two things, what we see is, first of all, we can see the origin of the problem. The reason that we've got difficulties in this particular panel is because we've got such a large standard deviation associated with the seedling effect that the observed values based on the 5 seedling heights can be quite different from the true values. So what we're going to try to do is we're going to try to correct for that through a process known as shrinkage. It'll be explained more in the next video, but the idea is we're going to take each one of these observed values and we're going to shrink those towards the mean, and in doing so, we're going to get a better estimate of what the true parent tree effect is. And the basis for this shrinkage, the amount of shrinkage is going to be determined in part by the variability of the seedling effect, relative to the variability associated with the tree effect, such that when you've got a large amount of variability associated with the seedling effect relative to the parent tree effect, a greater amount of shrinkage is going to be required.